Okay, Unit 10, second to last unit of the whole year. We're going to be looking at graphing exponentials and graphing logarithmic graphs. And you haven't seen these before. They're basically curves. Like exponential is like, oh, it's getting 2 times bigger every year. So it's getting bigger and bigger and bigger and bigger. That's why it curves so much. And logarithmic is just the opposite of exponential. So we're going to look at the parent graphs here. If you look at this equation, the b here is your base. It's always going to have an x as an exponent. The a is your multiplier. And your h and k are your shifts or your translations. H goes left and right, and it's always opposite what you would think. K is up and down. So the graph here, if you look, we're going to get 3 key points from our base that we identify. It's always going to have the x values as 1, 0, negative 1. It's the y values that are going to change depending on b. And the order you want to do this in is find the key points, do your multiplier to the y's, just the y values though. You're going to plot those points, and lastly, you're going to do any shifts before you connect the dots. The other thing I forgot to mention is that on this graph there is an asymptote here, and will always be at y equals 0 unless you shift it up or shift it down. So you will have to identify that and mark it on your graph. The other graph, logarithmic, same kind of format. This b here is your multiplier. Not your multiplier, oh my goodness. It is your base. Your multiplier would be in front here if you had one, but our homework assignments aren't going to, so you're lucky. H and K are our shifts. This going left and right, this one going up and down, but remember left and right goes the opposite way because of that negative. Now, usually you'll see log of base 7 or log of base 2, but if it has a no log written, so like if it's log x minus h, you can put a 10 here if you need it. And then log e, we sum up as ln, and so you can always rewrite it like this. So ln always has base e. It's just kind of weird, but it happens so much in nature that we use it. For our key points here, the y values are always going to be these 3 numbers, but our x values are going to be changing based on b. Now notice, if that's a fraction and b is, let's say, 1 over 2, this right here becomes 2 over 1 or just 2. Just a heads up. When you flip a fraction, it just makes the whole number there. And you follow the same order as we did before. Now this one I also forgot to put on here. There is an asymptote at x equals 0 unless you have a shift left or right. If you shift the points left and right, the asymptote also does. Okay, so that's what I just went through kind of in words. You will want to find domain and range for these once you graph them, but it's easier to find them once you graph, just a heads up. So let's try this. Our base here is 3, our multiplier is 2, and we have no shifts. That's kind of the 3 things you look at right away. Our key points here, x, there's no log, x is an exponent, and so we're going to use the exponential key points, which were negative, 1, 0, and negative 1. And 1 always goes with b, 0 always with 1, and negative 1 is always with 1 over b. And then we're going to take the y's, so your y times 2, and that becomes 1 and 6. Notice the x didn't change, only the y. 0 and 2, and negative 1 and 2/3. And that's where you go and you actually plot these. So we've got 1 and 6. Notice here, each line here is a half line. So just beware. We've got 0, 2. We've got -1 and 2/3. And we also have an asymptote right here. And then after this, if there's any shifts, now would be the time you do it. Which we don't, so we just connect the dots. Ooh, that was a bad line. And it should be a nice curve with arrows. And I write down where my asymptote is. And it didn't move, so it stayed at 0. So that's right here. My domain for exponential graphs is actually just infinities, which is nice. It always goes left to right forever. You can also write all reals. That's how the answer key might show it. Range is low to high, so the lowest point is that asymptote all the way to infinity, or you can also write y is greater than 0. It stayed on the upside. So that's your final graph. That's as much information as you need. Make sure you put these 3 things on your homework. Let's try a log now. So remember, ln is actually log e. And if you notice here, the base is that e. Oops. E is 2.718. I forgot to say. It's a button in your calculator. Excuse me. It's a button in your calculator, or you can use that 2.718. We don't have a multiplier. And our shifts are right 1 and down 3. So when we go to our key points, remember the y values are now the ones that are those constant 3 numbers. 1 always goes with b, which is e here. 0 with 1, -1 with 1 over b. And there's no multipliers. So I'm just going to make these all numbers here. And gotta do some quick math here. 1 over e is 0.368. You don't need that many decimals, but I'm just going to use it so you have them just in case. So go ahead and graph those. Oops. So 2.7181 is about here. 1, 0. 0.368 and -1. And then our asymptote. Remember, logs have an asymptote that's vertical. And then we're going to shift them all over by right 1 and down 3. So right 1, down 3. Right 1, down 3. Right 1, down 3. Including our asymptote. Because we still want something to follow that curve with. And that is at x equals 1 now. So we have x equals 1. Here, let me show you that bigger graph here. There we go. You can even go all the way off the graph if you want. Our domain for these actually starts at our asymptote. So here it's 1, because remember the asymptote moved. You can also write x is greater than 1. And then our range goes on forever. So if you notice here, I wish I had a pen. Domain and range here, and domain and range here are opposites for which one gets the infinities. And that's it.